Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series. Our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is measuring structural quality of applications in ADM using software analysis and measurement solutions. Our guest speakers today are Dr. Bill Curtis, Senior Vice President and Chief Scientist CAST, and Mr. Rajesh Nayak, Director, Sales and Business Development, CAST Software. Dr. Bill Curtis is an industry luminary who is responsible for influencing CAST's scientific and strategic direction, as well as helping CAST educate the IT market to the importance of managing and measuring the quality of its software. He is best known for leading development of the Capability Maturity Model, which has become the global standard for evaluating the capability of software development organizations. Bill has a passion for software analysis and measurements because after improving development process, it is the next wave of software engineering improvement. Prior to joining CAST, Bill was a co-founder of TerraQuest, the global leader in CMM-based services, which was acquired by Bolland. Prior to TerraQuest, he directed the Software Process Program at the Software Engineering Institute at Carnegie Mellon University. Prior to the SEI, he directed research on intelligent user interface technology and the software design process at MCC, the fifth generation computer research consortium in Austin, Texas. Bill holds a PhD from Texas Christian University, an MA from the University of Texas, and a BA from Eckerd College. He was recently elected a Fellow of the Institute of Electrical and Electronic Engineers for his contributions to software process improvement and measurements. Mr. Rajesh is a hand-on business leader, sales strategist, and business technology evangelist with around 17 years of global work experience in the IT industry, spanning across enterprise software solution sales, product strategy, product marketing and management, business development, pre-sales, product R&D, IT consulting, and software service delivery. He expertise in identifying new business opportunities, conceptualizing and creating unique and differentiated solutions offering to capture value pockets. He has demonstrated ability in selling business solutions with fact-based ROI models and business justifications. Rajesh is a successful team manager and mentor with the ability to identify and groom talent and create motivated, high-performing teams. Also, he has been a popular speaker at industry forums, conferences, and trade shows. He is MBA in Strategy and Marketing from INSEAD and was the university top 10 rank holders in Bachelor of Engineering from the University of Missouri. So without further delay, I introduce you all to our guest speakers. Over to you, Bill.
Okay, thank you. Can you see my screen?
Yes.
Okay, show my screen. Here we go. Okay, well, welcome to our webinar today. I'm going to give you an overview of how to measure and manage the structural quality of large applications. And then Vinod will talk more about some other issues related to that. So let's start. The fact is that we're seeing more and more outages almost on a daily basis, and some of these outages are costing $1 billion. The outage at Knight Capital forced the company to be recapitalized. It was a $430 million disaster because a new update accessed some dead code. The RBS outage cost upwards of, they reported 175 million pounds, but it was probably much more than that. So we know now that software quality is a very expensive issue, and it's getting on the agenda at the highest levels of the corporation because of the potential risk, financial risk to the corporation when software outages have devastating business effects. Mostly these are generally not functional problems. we're pretty good at functional testing. We pretty much know how to go about writing test cases from the functional specifications and identifying where the functional problems are. Most of these outages are caused by structural flaws in the system, and I'm going to talk more about that because that is an area that has historically been underrepresented in quality assurance activities in large organizations. First, let's start with the notion of an architecturally complex defect. Defects that occur in a single component are reasonably easy to detect. You often detect those with unit test cases or freeware static analyzer off the net that will analyze a couple of components. And so you can clean up the components fairly well. It's these architecturally complex defects where you have a number of different components interacting in ways that were never intended or in ways that cause severe problems in the application. These are the ones that are most devastating and the ones that we need to detect, and they can't be detected at the unit level. They have to be detected when you look across the entire application. For instance, it ends up, the research on these kinds of defects shows that they only account for somewhere between 8 and 10% of all the defects in the system. Most defects are down at the component level. But these architecturally complex defects take up over half of the effort that organizations spend on fixing defects. So while they aren't all that frequent, they're devastating in terms of their impact on costs, application costs, and on how we spend maintenance time. And in fact, the reason that they take so much time is that they often require 20 times as many fixes because I have to apply these fixes to a number of different files, a number of different components in the application. In fact, it frequently takes a number to complete the fix because as you fix some of these components, you realize that other components were involved that you haven't suspected, and now you've got to go fix them as well. Another problem is that we see, oh, I'm trapped here. What's wrong? There we go. We see that certain components end up being involved in a number of these architecturally complex defects. In fact, 80% of architecturally complex defects touch one of these components that has a lot of other architecturally defects running through it. In essence, we've got some components that were so badly designed or so badly coded that they're causing problems throughout the system that are involved in multiple different architecturally complex issues. And if we can find and detect those architectural hotspots and go fix them, we can have the maximum impact on the overall integrity of the system, the cost of the system, the total cost of ownership, and the quality of the system in operation. So let's look at 3 different levels of application quality. The first level is the code unit level. This is what I would do as a programmer or as a developer. I'd build my components, and I want to make sure that before I submit them to the build that they're of high quality. So I've got some freeware tools I pulled off the net, some static analyzers, and I run those on my code and to make sure that this is well-constructed components. And I run my unit test cases to make sure the functions are right, and then I submit them to the build. Well, that's fine, but there's 2 levels above that. The next level is the technology level. And let's say we're looking at all the components written in Java. Let's say our whole business logic was written in Java. So I've got all these different components written by multiple developers, probably multiple teams, and they've got to all interact in appropriate ways to make sure that the business functionality occurs and is processed as we expect it should be. This is more complex than just testing what I built as a developer. And so generally we have to move towards commercial tools to analyze this level of complexity across all the components built in a single language. But that's at the technology level. The problem we have in modern applications is that they're a stack of technologies. A modern application has different layers, each of which may be built in a different language sitting on top of a different platform. So I may have my business logic written in Java, but I've got some frameworks, Spring and Struts and others that make it easier to work with the Java. I have some middleware that allows me to interact with other systems. I've probably got a different language in which we've built our user interface. Then I've got all the SQL components that are basically accessing the database, which is down in, it could be Oracle, it could be IBM, it could be a number of other different types of technologies. I may be accessing an ERP system, so we've got some customized language like ABAP that we have to deal with. And if you're in a bank, you're probably interacting with an ancient COBOL system as well. So any of these applications or modern applications, especially if they're business critical, are a stack of technologies, which means that we've passed the point at which any single individual or even any team can understand all the interactions among all the different components in a modern application. And so we have to have automated help to go analyze this stack and rebuild it and understand all the different interactions across all the different levels and technologies. And that's the strength of the artificial intelligence platform that CAST has developed, is its ability to go across multiple languages and reintegrate all that data so we can represent all the control flows and data flows and class hierarchies and all the other different aspects of a modern application and how these different layers and technologies interact. Most of the system architects that I talk with, the application architects, the chief architects in organizations, complain that the biggest problems they have are not at the component level. They're at the level of the interactions among these different technologies and these different layers, and that's where the most insidious defects hide. So we've got to address that. Now, I'm going to pose something to you here. You know, we can look at the code unit level where the developer is doing his or her work, right? And they're running some functional test cases. They're running their sort of unit level test cases, and they've probably got some freeware where they're doing a static analysis, right, of their components before they put them into the build. And then they submit their components to the build, and immediately, once we build the software, we run some functional tests. We run our integration tests. We probably have some regression tests we run, but we're really testing the application for its functional correctness at that level. The question is, what do we do at the structural level? What do we run after we integrate the software to detect structural flaws that are in the system? The same way we ran our regression tests and all our integration tests to make sure that the functional aspects of the software were correct. The fact is, many organizations don't do anything. And so they're submitting code to operations that, while it's functionally correct, hasn't been analyzed to make sure that it's structurally sound and won't cause outages and data corruption and security breaches and other kinds of problems. So if functional testing at the code unit level is inadequate for a release, and you know you have to do functional testing at the integration and system level, why would you think that analysis with freeware at the code level is adequate? You really need a strong analysis of structural integrity of the system, of the application at the system level. And this is done after you do the build. It's not something that developers do. It really has to be done at the integrated build level. So this is what we've worked on for over a decade now at CAST, is trying to build the technology to fill that gap, to do structural analysis at the system level. And so we have parsers that will parse any of 28 languages, the most popular languages in most business applications, as well as a universal analyzer that will analyze any of the languages we don't have dedicated parsers for and give us a partial parse. And so we take all that data from the parsers, we reintegrate that to represent at an abstract level the interaction and structure and the structural aspects of the entire application across all its layers and across all its languages. So we can now trace the data flows and the transactions, the control flows, the object hierarchies, and what have you. And in that, we have written 1,200 rules for good coding and architectural practice. And these are rules that deal with things like performance, reliability and robustness, security, various aspects of maintainability like transferability, which is really how comprehensible the software is, and changeability. And so you can see that we're looking for these violations. So for instance, look in the middle there at security. Those are the 4 of the most common violations of good architectural and coding practice that lead to security problems: SQL injection, cross-site scripting, buffer overflow, uncontrolled format strings, and what have you. So we search for these, and we detect these, and we provide that feedback back to the development team and to the application manager, giving them metrics to describe the quality of the application on these various dimensions, as well as providing developers with the ability to drill down directly to the point in the code where these different kinds of violations occurred, so they can make decisions about which ones to prioritize for remediation. So it's a very powerful technology that looks at the structural aspects of an entire system and can identify these large architecturally complex defects that involve numbers of different components that are spread across several layers and several technologies within a large application. In addition, because we look at the entire application from the user interface down to the database, it gives us the ability to automate function points. And so we can actually go into the source code and with an automated technique identify all the transactions in the application and develop a count of the function points that's automated. We've calibrated this with manual counters, and it tends to be very, very consistent. It tends to be a little bit on the high side, but manual counters can vary by as much as 10 to 20% themselves. So this has been very effective for us. We find a number of people finding this to be just as valuable as having the quality results as the ability to do sizing with something other than just lines of code. Now, what this has led us to is the fact that people want to use these automated metrics for quality and for size. And in fact, we're seeing more and more that these are being written as service level agreements into contracts for system integrators and for outsource organizations. And a number of the outsourcers, especially the outsourcers in India, went to the Software Engineering Institute at Carnegie Mellon and went to the Object Management Group, which is a well-known standards organization, and said, look, we need help. We understand that we'll get these quality metrics written into our contracts, but the fact is we can't deal with every customer having a different version of the metric. We can't deal with 75 different versions of what a reliability measure is or what a maintainability measure is. We need one international standard that people can use in their contracts. We all know what it is, and with the organization focused on trying to maximize a consistent measure across the whole organization for all of our outsourcing contracts that have that kind of an agreement written into it. So that led to the development of the Consortium for IT Software Quality, which was co-sponsored by the Software Engineering Institute at Carnegie Mellon and the Object Management Group. Since I work with both of those organizations, they asked me to be director. So we formed this in 2010. Tata was, in fact, one of the very earliest members. We also had Cognizant and 3i Infotech and HCL and some other Indian organizations join and participate in the development of the metrics. We held executive forums to determine what we should work on. Those were held in Frankfurt, Germany, in Washington, D.C., and in Bangalore. And based on that, there were 4 quality metrics that the executives that participated in those forums asked us to create automated measures for. Those were reliability, performance efficiency, security, and maintainability. In addition, they asked if we would take on the challenge of producing an automated or a specification for automating IFPUG-based function points because they needed a good consistent size metric they could automate to evaluate how large the code was that they were delivering to a customer, and for improving their ability to do better estimating up front from specifications. And so between 2010, 2011, and 2012, these teams met. We met in Europe, we met in the U.S., we met in India, and worked on creating these specifications. We have completed all the specifications. The one for automated function points has been submitted to OMG and is now a supported specification, which means it's a standard supported by the Object Management Group. The other 4 measures are being prepared in OMG's various meta models, and we expect that they'll be submitted and hopefully become OMG standards next year. And from OMG then, they ultimately get moved over through OMG's fast track over to ISO. But at OMG, they become standards. They are supported specifications that are available for free. In addition, these metrics are available on the CISC website. We have a website we invite you to go to where you can access these standards in the members area. Membership is free. CISC is now supported. We have industrial sponsors that support CISC, that provide the funds for CISC operation. Currently, the sponsors are Capgemini, CAST, and Huawei, the Chinese telecommunications organization. And other organizations are talking with us about becoming CISC sponsors as well, and sponsoring some of our future work on the next set of metrics that the organizations want us to work on, in addition to providing guidance on how to deploy these. In fact, we've been holding seminars. I just held one yesterday in Berlin at the OMG meeting where we had 30 executives come, and we were talking with them about how to deploy these measures in their contracts, as well as using them internally to improve their own quality and productivity. So I invite you to join CISC, especially since it's free. The standards are inside the members area. There's blogs. There'll be an increasing amount of material related to the structural quality of applications that's available inside the CISC website to members, and it helps us drive the message that it's critical to get to invest in the quality and the structural quality of these large information systems in order to avoid the kinds of devastating outages we've seen recently that can cost upwards to $500 million in terms of the damage they do to the organization. So I encourage you to join CISC, and let me turn it back over now so that we can go to the next part of the webinar. Rajesh? Vinod? Hello?
Yeah, thanks, Bill. So I guess everyone can hear me all right now, and you can see my screen as well. So what I'm going to cover in the second section is I'm going to get into more details on what Bill shared and the applicability of these details from an ADM perspective. And I'm also going to cover a bit of CAST as well. Okay, so a very quick word on CAST. So CAST is the market leader in software analysis and measurement, the space that Bill was talking about. And software analysis and measurement today is a very well recognized area by leading analysts and thought leaders. From an organization perspective, we've actually spent over $100 million in developing IP that actually looks at the kind of system level defects and violations that Bill was talking about earlier. And we've been investing millions and millions of dollars every year to actually, get to our ambitious mission, which is in terms of transforming application development and sourcing into a management discipline, right? By providing measurement and transparency all along the life cycle. From an ADM perspective, if you look at the screen, you'll see that software analysis and measurement, like I mentioned, has been recognized, and there are a lot of contributions from key influencers like the McKinseys, BCGs, Gartners, and IDCs. And Bill shared a lot about CISC earlier, and the contributions made by SEI and OMG on that. So we currently have over 250 global leaders who actually completely rely on CAST and have kind of matured in the software analysis and measurement journey. And we also have a lot of global SIs who partner with us, and they're using and reselling solutions using CAST. So that's a quick introduction on CAST. So kind of quickly to go into the application intelligence platform and how CAST actually does what we covered earlier, right? So from a platform perspective, at the lowest level, the raw material to the CAST application intelligence platform is the source code of the application, right? So without the source code, you would pretty much not be able to, do any kind of structured analysis, which is very obvious. So what CAST does is it takes the application source code and then it kind of runs it through the AIP analytical engine. The AIP analytical engine has over 1,200 plus rules and best practices. So the engine applies these to the source code and then looks at how the source code behaves or is with respect to these best practices and and rules. And what it then does is it kind of then looks at various other things like priorities that have been set by the application owners, users, etc., and then boils it up into the measurement platform, right? Which is a platform which actually provides visibility to ADM management in terms of the overall structural health of the application. So Bill kind of referred to this earlier in his session. So the measurement platform provides actionable visibility into what we call as application health factors, which specifically focus around application performance, robustness, security, maintainability, and changeability of the application. And these are all health factors which directly map to CISC metrics, which Bill mentioned earlier, right? So these health factors overall provide a clear view into the structural health of the application. And going back to Bill's slide earlier, right, it kind of provides visibility into that question mark which was there on the right corner from a application structural health perspective. So it kind of gives visibility into that, so management can quickly take decisions into whether the risks of the application warrant it to be actually put into production or not. At a lower level, what CAST actually also does is it helps you to drill down from the measurement platform to the engineering platform, which is actually a drill down into the root cause of what the health factors show. Or if, for example, if an application is actually poor with respect to robustness or resiliency, right? So what are the actual reasons why is it poor, right? So either what's the problem with the application? So that's something which you would be able to drill down with the engineering platform, which will allow you to kind of drill down all the way to the source code of the application, right? So you would be able to actually go down to the source code and look at specific violations which are critical in nature and which are actually contributing to the poor health scores of the specific application. And finally, the engineering platform also gives some kind of recommendations and insight to developers who would actually then, possibly work on fixing or remediating some of these critical violations, right? And ensuring that the application meets desired risk levels before it actually gets into production. So I'll quickly get into a little more detail into what Bill had mentioned earlier in terms of how CAST is actually able to do this, and what's it that we've built and been spending like $100+ millions on, right? The kind of IP we've built, which actually covers at a system level or a very comprehensive level these kind of architectural or multi-component defects. So what CAST does or what kind of uniquely differentiates us is actually our ability to connect the dots, right? So we're all very familiar with code checkers, right? Code checkers, monolithic code checkers that we typically use in a projects like PMD, FXCOP, etc., right? And we kind of use these, as you saw in the earlier section, in terms of ensuring code hygiene, in terms of looking at violations at a component level. But then today, we know that applications are not monolithic anymore, right? So we don't really have an application which is just on C or C++ and things like that. So today's application actually go across, for example, JSP or ASP.NET, and then they go across to Java and then to the database and things like that. And not only that, so you today have a lot of other things which actually help you and in turn make the application more complex, which is frameworks, right? So you have frameworks like Struts and Spring and Hibernate, JPA, etc. And what happens is each of these layers or technologies actually talk to each other, right? So you would have, for example, a JSP talking to a Struts, and then it talks to a business layer in Java, which then uses Hibernate to actually talk to the database. And And this is what CAST is actually spent all its R&D dollars on, in terms of helping to connect the dots, right? So what CAST actually does is it has the ability to look at all these technologies and then string them together or connect the dots, right? And what it typically does is it splits an application into multiple objects, right? An object is something typically which has complexity in it, right? Like a function or a method or a class and things like that. And CAST kind of breaks the whole application, the end-to-end application across technologies and layers into objects, and then builds a meta model on top of that. And then this ability actually helps it, to help you in ADM in a variety of ways, which I'm going to cover in a minute. And it also helps you in terms of the function point section that Bill covered earlier, right? Because what CAST does there is, with the ability to actually connect the dots, it can actually, understand the application in full detail and look at, how things are with respect to how many times does, for example, it access the database and what are the business logic involved. And so it kind of completely reverse engineers an application and is able to compute in an automatic manner the function points. So just quickly coming back to this, so we've covered our unique ability to connect the dots actually helps CAST to provide a context-based end-to-end picture of an application, right? And this is very important to understand. So for example, if you look at the right side of the screen, you will see that there are a lot of critical violations listed, which are actually in some of these functions and classes. So you have critical violations like, avoid SQL queries on XXL tables, which do not support a composite index and things like that. But what's very important here is, so CAST, with its ability to connect the dots, can actually, bring context here by, see, if you look on the left side, you see that here in this specific case, there are 98 objects which are actually referring to this transaction, right? So when I look at the context, I'm actually more concerned about something which has, for example, 98 other objects referring to it or is being referred to and things like that, rather than maybe another object, which is only being referenced by 3 or 4 objects, right? So this kind of context actually helps me to quickly pinpoint and prioritize my efforts and, help in reducing risk to a greater extent. And so what we can, and finally CAST can actually do this across multiple technologies, right? So it's not just one single technology. CAST can actually do this across multiple technologies. So an application finally is actually all the technologies or all the source code across, maybe it's a Java or database or middleware and things like that. So everything, all that is one single application for CAST, and CAST looks at it from an application quality perspective. So quickly moving on to the applicability from an ADM perspective. So our ability to actually connect the dots and then, have a comprehensive view of the application helps us to provide a lot of value in 2 specific use cases in ADM. One is in terms of helping in large ADM transitions in terms of the ability to reduce transition risks and costs. So here we help in terms of actually reducing the number of trouble transitions, improving the effectiveness of transitions, and then consequently reducing the risk of delivery in steady state. And I'm going to cover this in slightly more detail in a couple of minutes. So from a transition perspective, we actually bring significant benefits that are clearly quantifiable. We typically bring around 20% time reduction in knowledge transfer, and overall in terms of 10 to 12% productivity gains in very large transitions. So whether you are, part of a large global service provider who is actually transitioning large applications, maybe from in-house teams of a customer or from another vendor, or if you're, maybe part of an offshore development center and you're actually transitioning very large applications from your parent organization in the US or Europe or wherever. So CAST can actually help in the large transitions by helping you to reduce the risk of transitions and also to be much more effective in the transition from a time and cost perspective. We'll quickly get to that in a minute. The second use case from an ADM perspective where we bring a lot of value because of what we shared earlier is in terms of industrializing ongoing large AD and AM steady state delivery projects by applying lean principles. So here CAST actually helps to achieve a lot of productivity improvement objectives year on year on these large projects, and also in terms of assessing the structural quality of key AM and AD applications at every major build or release. So all this actually helps in terms of ensuring first time right, or ensuring that you kind of do it as early as possible in the life cycle, so that you kind of don't let these violations or things which can actually result in defects later occur later in the life cycle or in production, where it's actually much more expensive to fix. So overall, quick from a CAST impact for an organization, I'm going to cover more on the use cases which I talked about in the last slide. Is in terms of helping to mitigate risk, reduce costs, and create visibility. And there are also other ways where organizations have used CAST in terms of enriching their brand and equity by showing or looking at software analysis and measurement, and CAST as an innovative way to actually deliver more innovative services to the customers. To go to the first use case, which is in terms of ADM transitions. So from a transition perspective, CAST actually helps transition teams with fact-based insight to identify the riskiest modules upfront. So with the ability of CAST to actually look at applications from a holistic perspective and identify which are the risky areas. So what you can usually do is you quickly identify the risky modules up front, and then you can then allocate specific resources, right? So if you realize that module A, for example, is risky, and the module A is of technology A or B or C, right? So you can quickly assign an SME or a technical expert who is well versed in the technology, right? So this is something which quickly helps you to identify the modules which need urgent attention, and also get time with SMEs at the customer side, right? So that you can do a very effective knowledge transfer on these risky modules. And this is something which actually helps quite a bit in terms of prioritizing and reducing overall transition time. And then for service providers specifically, right? So this kind of insight actually helps them to push go live, for example, if it's from another vendor, right? By highlighting those areas of structural risk which can possibly lead to support issues in production, right? So this kind of gives you a quick visibility which you would typically not have otherwise, right? And then not take unnecessary risk if you're kind of going to maintain those applications in production and things like that. And also, obviously, if there is an opportunity, to look at specific change request opportunities, looking at identified critical violations and trying to see if some of them need to be urgently fixed because they are of a critical nature and can actually pose a significant risk to the application in production. In terms of the other key benefit from a transition perspective, so CAST AIP actually helps to generate key technical documentation. So the knowledge recipients or the secondary knowledge recipients, or in terms of knowledge transfer from on-site and offshore. So CAST actually helps to actually crunch that time significantly, right, and kind of bring significant benefits. From an ADM steady state perspective, so what CAST again does here is, so you look at the transition part, right, where you can quickly identify which are the modules which need attention. You can speed up your transition and things like that. So when you get to steady state, what you do typically is you kind of have you baseline the quality of your application with an analysis, and this kind of helps you with fact-based measurement in terms of demonstrating issues which have been inherited from maybe the in-house team of the customer or from previous vendor if you're kind of taking it from another vendor, right? And for people who are part of maybe an offshore ODC, it would typically be trying to baseline the application which you have actually acquired from your parent corporation somewhere else in the world, right? And then look at, for example, look at the critical violations and focus on correcting them as early as possible in the life cycle, right? So this is a key thing in terms of applying lean principles and reducing overall rework. And this kind of helps in gaining significant productivity benefits. Another key benefit which you typically get in steady state is in terms of being able to showcase positive evolution of structural quality since you begin maintaining the application, right? So for example, you kind of taken the application from another vendor or from an in-house team, or maybe you've taken it from your parent corporation. So you can actually, after a couple of releases, show that you have actually been improving the application and you've not been adding critical violations, or for example, you're not adding technical debt to the application and making the application even worse than it was, right? So this kind of helps you to overall show that you kind of improving the application, and shows you in a good light and gives you fact-based support in terms of showing the kind of things you're doing with the application. And finally, the ability to actually understand, where are the risks and where are the costs, and which are the technology modules maybe which are risky and which are not, and things like that, actually helps you to identify potential resource arbitrage opportunities. So you can, so places where you're actually, maybe putting a very senior resource, once you kind of fix certain critical violations and realize that things have actually improved, you can then, change the senior resource to maybe a less senior resource, right? And you can actually optimize on that in your fixed price or managed services agreements, and gain significant margin improvement on that count as well. And obviously, just as it kind of was helpful from a transition perspective in terms of transition discovery and things like that, from a steady state perspective, it again offers a lot of benefits. Cast's ability to actually give detailed, application maps or blueprints helps to optimize and accelerate newcomers induction. So this is again a significant benefit from an ADM steady state perspective. And finally, Cast, while you saw it from a while you saw that at the root it was actually looking at the source code, Cast as such is more of a management visibility solution, and it actually helps to gain visibility across the board for top management, right? So top management, ADM management, delivery heads, and COOs, etc., can actually look at the Cast corporate-wide portal and look at things at an organization perspective, or kind of slice and dice that across regions, geos, and verticals and things like that, and then at a click be able to gather information on the structural quality of applications within a portfolio, right? And then obviously take remedial action, take timely remedial action, right, with the visibility they've acquired. And this kind of quality monitoring obviously also has its own benefits. And to kind of summarize all that into a business case, what we typically see that typical outcomes for an organization include like 8 to 12% productivity gains, and the break-even is typically around like 8 months for any kind of investment in an ADM industrialization initiative using Cast. I guess so. I guess that's the end of my section, and I would turn it back so that we can actually get into the Q&A session.
Thanks for the insightful presentation. Let's quickly take up the questions now. Please read the questions and their answers so that all our users may listen to the commendable insights.
Neha, can you share the questions on the chat, please?
When I'm getting the questions, I'll assign the questions.
Okay, thank you.
Hello.
Hello.
Bill, I have assigned you the question.
Is the tool able to analyze for VB at Visual Basic applications and scripts? Rajesh, you want to take that one? We do have a parser for Visual Basic, yes.
Okay, I don't see the name of the asker, but yes, so yeah, we do support VB, Visual Basic, and script as well, VB script. I have a question from Tilak Goswami here. It says, is it similar like IBM V3R7? So I'm sorry, I don't really understand the question, but I guess it's not, right? So it's not, it's more focused towards software analysis and measurement. It's definitely, I guess, not similar to IBM V3R7, whatever that is.
Can we generate the functional documents? You mean requirement specifications? Depends on what we mean there. I mean, we're focused primarily on structural, so we can generate structural representations of the application. But if you're talking about the functional specs and the actual semantics of the functions, no, that's not the area of our focus. Let's see here. How do we get this to expand? Yeah, okay, so question here, two questions. Does the tool do the application documentation? The answer is yes. We do structural documentation of the application, more than just the health checks. Second, is there a personal edition? This is not working. Is there a personal edition or trial non-commercial edition of the tool? And the answer there is no. This is an enterprise tool because you're analyzing entire applications across across a number of developers or a number of teams if it's large. And typically the trial is more of a pilot where we run an analysis of an application so the organization can learn what kind of data is provided, what kind of defects they discover, structural defects, and how the tool can be used within their environment. Let's see, is this compatible? Rajesh, you want to take some of these that are more on specific aspects of the tool, like is it compatible with the AAL version of SAP?
Bill, I don't see the questions on my screen.
Okay, I'm having a hard, I've got a real small window that they came up in. It's hard to read these things. There's a question here. Whether we currently can analyze the AAL version of SAP. Okay,
so we do support SAP out of the box. For specific versions, I guess we'll have to specifically check the compatibility offline. So if you have a case which is specifically involving SAP. You can actually reach us at connect@castsoftware.com and we can actually look at the specific version that you're looking at.
Okay. Another question here, if improvement attempts for one metric, for instance efficiency, are going to impact adversely the other, oh boy, this question was horrible, are going to adversely impact other metrics, does the tool highlight the scenario? After the fact, yes. I mean, we point out the defects, and if in, for instance, addressing a performance issue, you end up making the code less maintainable, you would see that in the next, in the results of the next scan, of the next analysis. But I'm not aware of anything in the tool right now that highlights a potential conflict in the way you would remediate, because different people will go about remediating it in different ways, and that's and so that would be much harder to automate. VB is compatible with that. Okay, Rajesh, there's a question here. What kinds of documents or outputs are provided? And especially the kind of documents, not so much the metrics, but the representations of the application that the application intelligence platform provides.
Right. So that's a good question, right? So since we have the ability to actually connect the dots and then have a comprehensive view of the application, we can generate a variety of technical documentation. So you would be able to kind of get call graphs. You would be able to get a complete transaction view as well, starting from the UI all the way to the database. You would get kind of ER diagrams and things like that, right? So you can actually generate a variety of documentation which would give you both transactional views and object level views of the application, right? So you can actually focus on one object and then right click and look at what are the called objects and calling objects and things like that. So, and you can look at the dependencies of objects, and you can look at a complete call graph as well, right? So both from a transaction and a call perspective. So it would actually provide you with detailed application blueprints. And people do actually use this for quick application discovery, for impact analysis, for bug investigation and things like that. And also for scenarios where they need to do some kind of reverse engineering of the application to understand more in details in some kind of application migration or transformation kind of scenarios, where they need to maybe migrate from a mainframe to maybe newer for example Java application, and they want to ensure that from this documentation that they're actually covering most of the legacy application in this, right? So I have a question here from Fateh Ahmad. The question is, does it have the flexibility to measure structural quality of all kinds of application, large scale and short scale? So yeah, again, this is a great question, Fateh. So CAST specifically, right, is focused, as you again saw from our customer list there, is focused on business critical, mission critical applications that are actually multi-technology, multi-layer and things like that. So most of these applications are actually large and complex enterprise class applications, which can possibly be, of sizes 1 to 5 million lines of code as well, right? So it does actually handle very large scale applications. And the obvious answer to the other thing, which is short scale, yes. So you can actually analyze very small applications, but obviously the value you might get in a very small application of say 25 or 50K LOC would proportionally be much limited, right? Because of the complexity involved in that small application. There's a question from Sudakshina Basu. The question is, which standard are we baselining while measuring performance efficiency, reliability, question mark. Do we optimize improvements on these parameters depending on cost, application area, transaction volume, etc.? So I think Bill covered, I think, CISC in some detail in his section. So when we baseline an application, CAST actually looks at specific health factors and also at something called as the TQI, or the Total Quality Index. So these are all aligned to CISC standards that Bill mentioned earlier. And these are standards which are again things which are common or are set to become common currency between customers and service providers and other stakeholders in the ADM life cycle. The second part of the question, do we optimize improvements on these parameters depending on cost, etc.? Yes and no, actually, because we do actually track evolution of the application across multiple releases, so we can actually look at critical violations that are added, deleted, or which still exist in the code, and these critical violations then kind of link back to the technical debt within the application, which is actually a dollar amount. So yes, you would be able to optimize improvements on these and link it to specific dollar amounts. Yeah, obviously, yes, you can track evolution for specific modules of the application, or applications which are maybe you can segment it by the development team on this application, right? So, for example, if an application is being built by five different service providers or vendors, you can actually segment code from these vendors and track improvements for every specific vendor as well. Okay, I don't have any more questions on my screen.
I have none either, and we're near the end of the hour, so maybe.
Bill, I have like a couple of questions which just came in.
Okay.
Let me look at them. Okay, question from Rajesh Shastri. How often do rules get added to the CAST repository? So Rajesh, so we have frequent releases of CAST, and obviously we keep adding to our repository with all the latest and greatest. And these are all again sourced from customers and from academic research and things like that. But I think more importantly, I just want to highlight that the CAST rules repository, if you call it that, is not static as such. So you have the ability to actually add custom rules to CAST. So CAST gives an easy platform to actually add custom rules. And on top of that, Bill had mentioned this in his section, you also have the ability to use the Universal Analyzer framework to actually create rules for technologies which are not supported out of the box as well. Other question from Rajesh Shastri, is Oracle EBS supported? We'll have to check for the specific versions. So I guess if you can actually connect with us offline, we can engage on that. Okay, no more questions on my side here on my screen.
And none on my side. So should the organizer come back on and end the session?
Yeah. Neha, back to you.
I'm just sending you.
Hello?
Hello, Rajesh, are you there?
Bill's here.
Yes,
Okay.
Neha, I'm here.
Yeah, I've just assigned you a question.
Okay, just let me look at it. Yes, there's a question from Rajneesh Kumar. The question is, can we change some of the rules based on need? The answer is yes. So CAST provides you the ability to actually change the priority of the rule or criticality of the rule. So for example, you know, there are organizations which might have security as a specific focus, and you might want to actually turn on all the security rules as being very critical. And you know, maybe banking and financial services organization might want to, you know, specifically enable some things on PCI compliance and things like that. So yes, answer is you can actually change the rules based on your need. And like I mentioned earlier, you can add additional custom rules as well to cater to any specific requirements of your organization.
I think that's all from the audience side. I'm really thankful to our guest speakers for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com by tomorrow. Thank you all.
Bye-bye.
Thanks everyone.
Bye.
Bye.